This is for mathematical methods. It's VCAANH Northern Hemisphere 2019 exam 1 question number 7. So we have a shaded region, and the shaded region shown here. I goes between 1 and 3 on 2, so it's in that section in there. Okay. So show that the shaded region is given by this. Okay. So this area will be the integral from 0 to a of top curve minus bottom curve dx, which is the integral from 0 to a. Top curve is sine of pi x minus bottom curve is this here. Now this here is where x is equal to a, so that's y equals the sine of a pi. So minus the sine of a pi dx. So that's going to be, the integral of sine is negative cos of pi x. The derivative of this, so that's negative 1 on pi. This is just a number, so minus the sine of a pi x from 0 to a. Putting in the a first, 1 on pi cos of a x minus a sine of a x, putting in the 0, plus 1 on pi cos of 0 plus sine of 0. That's 0, that's 1, so I've got 1 on pi minus 1 on pi cos of ax minus a sine of ax, and that's what I had to show that it equals, so that's good. So part B says determine the range of these values. Okay, the range of these values. A only goes from here to here. So when a equals 1, the area is going to be this, and that will be the smallest value of a, the area. And when a equals 3 on 2, the area will be all of that. So the minimum value of a is when a equals 1, and the maximum value of a is when a equals 3 on 2. And when a equals 1, the minimum value is going to be 1 on pi minus 1 on pi cos of pi minus 1 times the sine of pi. Sine of pi is 0, cos of pi is negative 1, so it's going to be 2 on pi. And the largest value is when a equals 3 on 2, and a of 3 on 2 will equal 1 on pi with this minus 1 on pi cos of 3 pi on 2 minus 3 on 2 sine of 3 pi on 2. And 3 pi on 2 is down here, so the cos is equal to 0, but the sine is equal to negative 1, so that will be 1 on pi plus 3 on 2. So the range values will be a of a will go from 2 on pi up to 1 on pi plus 3 on 2. So that is part B. Part C, express the area, express in terms of A, the area bound by this. So in terms of A of X or a specific value of A. Okay, so what have I got? If I've got 2 times the sine of x pi plus root 3 on 2, I need that between that and the horizontal axis. So set it equal to 0 to find the x-intercept. Then sine of x pi plus root 3 on 2 equals 0. Sine of x pi equals minus root 3 on 2. All stations to Collingwood. Sine is negative down there. For 3 on 2, theta is going to equal pi on 3. So that's 4 pi on 3 and 5 pi on 3. Therefore, x pi equals 4 pi on 3, or 5 pi on 3, which means x equals 4/3 or 5/3. And oops. So if I'm looking at what this looks like, it's 2 times the sine of pi x plus root 3. And that's 4 pi on 3, and that's 5 pi on 3. And if this area here is the same as that area there, when A equals 4 pi on 3. So what I need to do? Express in terms of A the specific area, or for a specific value of A, the area of that. So if A equaled 4/3, then this is the sine of 4 pi on 3, which is negative root 3 on 2, which means that's negative root 3 on 2. And if I move it up, that will be negative, that will be root 3 on 2. So if this is 2 lots, then the area represented here is 2 lots of A of A when A equals 4/3, because it's being multiplied by 2. Hence or otherwise, find the area enclosed in part C, part 1. Well, since it's going to be the same as this area, I can use this. When A equals 4/3, because 4/3 corresponds to this point here. So the area when A equals 4/3 is going to be this. So 1 on pi minus 1 on pi cos of 4 pi over 3 minus 4/3 sine of 4 pi on 3. 1 on pi minus 1 on pi times negative a half minus 4/3 times negative root 3 on 2. So 1 on pi plus 1 on 2 pi, which is 3 on 2 pi, plus 2 root 3 on 3. And since the area in this part, in part C part 1, is double the other, then my area is going to equal 2 times 3 on 2 pi plus 2 root 3 on 3. So the area should equal 3 on pi plus 4 root 3 on 3 squared